Hello, and welcome back for the video for lesson 7.5. This is all about graphing parabolas. Parabola is the shape that the graph of a quadratic makes. Okay, and it can look something like this, or it could look something like this, face down or face up. And it can move all around. It can be shifted all around. So we are going to learn how to find these things. The y-intercept, which is always when x equals 0, it's the y value. The x-intercept, and notice that it could have one intercept, two, or no intercepts. So notice the two that I drew here, both would have two x-intercepts because they cross the x-axis twice. But this one right here, this one just goes up and touches and comes back down. So that one just has one intercept. And we could have something like this, where it comes down and doesn't ever touch the x-axis and goes back up. So we're going to learn about those three situations. And then also the vertex of a parabola. It's the xy coordinate, where if you're increasing, it comes to a maximum and then goes decreasing. So that would be the vertex. Or on this one, it goes down, it's decreasing, and it has a minimum, and that's the vertex, and then goes back up. So here would be the vertex, and there would be the vertex. I'm just putting a V for vertex. And the vertex is found by, if your quadratic is in this form, ax squared plus bx plus c equals 0, all of the terms have to be on the left or right-hand side and 0 on the other, then you can find the x coordinate of the vertex by taking the opposite of b. So the opposite of b divided by 2 times a. And then you're going to put that x value into the function and you'll get your y coordinate. So I have several examples here today. So for each of these, we're going to give the x-intercepts and the coordinate of the vertex and sketch the graph. And I didn't write y-intercept, but I always like to do that. So the y-intercept is easy because I can put in 0 for x. If I put in 0 for x, this goes to 0. This goes to 0. And I'm left with a -3. So that's my y-intercept. So I'm just going to draw a quick graph. So 0 at -3 right here. There's my, now it's not necessarily my vertex, but it's where I'm crossing the y-axis. Okay, the x-intercepts. I'm going to look at factoring for the x-intercepts. That's my first choice. If I can't factor, I'm just going to go ahead and do the quadratic equation. So I think I can factor this into x minus 3x plus 1 equals 0. That will give me a -2x in the middle when I add them and a -3 out here. So I have x minus 3 equals 0. So I have 1 at 3. And then when the x-intercept is at x equals 3, and that 0 is what we call these. So that the x value when y is 0. So that's 1, 2, 3. There's 1. And then this one is at x plus 1 equals 0. When I subtract 1, I get a -1. So this one is at a -1, 0. Okay. Now, because these 2 points have a y of 0, I could add the x's and divide by 2. So take the average of the x's, and that would give me the very middle where the vertex is. So just to show you what that would look like, 3 plus a -1 is 2 divided by 2 is a 1. So I think the vertex of the x value of the vertex is at a 1. But we can find that using this formula right here for the vertex. So the x is going to be a negative of b over 2a. And so that's going to be the opposite of a -2, because b is a -2 over 2 times a, which is 1. that becomes 2 over 2, which is 1, which is what I set up here. So those match. And then my function evaluated at 1 gives me y. So 1 squared minus 2 times 1 minus 3 equals 1 minus 2 minus 3 equals 1 minus 5 is a negative 4. So my vertex is at 1, negative 4. So 1 and then down to negative 4. Okay. Now, there's a few other things I wanted to point out. That your A, so in your quadratic equation, when it's all to the one side and set equal to 0, if A is less than 0, then it's going to be a face down parabola. Okay, if A is greater than 0, then you're going to have a face up parabola. And so because our A is just a positive 1, we already know it's going to be a face up. So that kind of gives you some hints of what your graph should look like. And you can check these by putting them into Desmos. I will put a few in here and there today. Okay. I'm going to have a 2-part video here. So there's some extra ones. I won't do them all in this video, so you can check out the extra video if you need it. Okay. So this, I'm gonna skip B. So let's look at this one. So this quadratic, we have A equals 1. There is no X term, so B equals 0, and C is a negative 4. Okay, so let's look at our y-intercept when X equals 0. So when X equals 0, I just have a negative 4. That. And then my x-intercepts, my goal is to factor first. That's always the easiest if I can. And this x squared minus 4 is a difference of squares, so it factors into the conjugates of x minus 2, x plus 2 equals 0. And so x minus 2 equals 0 gives me an intercept of x equals the 2. And the other one gives me an x-intercept at a negative 2. So 2, 0, and a negative 2, 0. So here's 1, and here's 1. And then my vertex, the x is at the opposite of B, which is just 0 over 2 times A. So x is 0 on my vertex. So that means the 0, the y-intercept is also the vertex. So the vertex is at 0 and a negative 4. So it's this one right here. Okay. So let's look at letter D. So letter D, I'm going to write down my A is a negative 1. And it's less than 0. So I know it's going to be a face down. Okay, because A is a negative 1. B is 0 again, and C is 1. So I'm just getting this ready for a quick graph. So on the y-intercept, I'm going to put 0 in for x. And so if I put in 0 here, this is 0. And so the y-intercept is at 0 and 1. So we know that it's going to cross the x-axis because it's face down, and the y-intercept at least is above the x-axis. So I know there's some x-intercepts. And so when I set my equation equal to 0, I can subtract 1 from both sides because I can't factor this, well, so let's just leave it like this. I'm going to subtract that. So I'm going to divide both sides by a negative, and then I get x squared equals 1. So that means that x could equal a -1 and x could equal a +1. So those are my x-intercepts. And then on my vertex, I'm in the situation I was before, because b of 0, my x coordinate on my vertex is the opposite of a 0 over 2, -1. So it's 0. So my vertex is at 0, 1. So it looks like this. Okay. So I am going to leave E and F for the extra video. If you want to check them out, you can. And then moving on to the second part of the lesson. Sometimes the quadratic comes in what we call vertex form, okay? And when it's in vertex form, it's actually much easier to find the vertex and graph it, but it's a little bit trickier to find the x-intercepts. And so it says graph each parabola, label the vertex and any intercepts that exist. So let's just see what we can do here. So the y-intercept is a little bit trickier to find too when it's in this format, because it's not just, this isn't just going to go to 0 now. So my y-intercept here is going to be 2 times 0 plus 1 squared minus 3, because I'm still putting 0 in for x. So 2 times 1 squared minus 3 is 2 times 1 is 2 minus 3 is a -1. So my y-intercept is at 0 and a -1. There we go. And my vertex is the easy piece, because my vertex is H and K. And in this form, A is still the same. A still tells us if it's face up or face down. And so A is equal to 2, which is greater than 0. So I know it's face up. So it's going to have some x-intercepts. I just don't know where they are. But H and K are found in here. So what's in the squared piece is the H. So the opposite, so because it says +1, that means H is a -1. And K is exactly what we see. So if it's plus K, then it's a positive. If it's minus K, then it's a negative. So it's a -3. So the vertex is at a -1, -3. So there's my vertex right here. Okay. And then my x-intercepts, I have to set my equation equal to 0 and solve for x. So I'm going to add 3 to both sides and divide by 2. So 3/2 equals x plus 1 squared. And then we would take the square root of both sides. So this will be the square root of 3 over the square root of 2 equals x plus 1. Plus or minus. So this is going to be plus or minus. So, and then equals 1. So, or plus 1. So we have to subtract 1. So it's going to be plus or minus the square root of 3/2 subtracting 1 equals x. So we would have to go to Desmos to find this. So I would have the square root of 3/2, and then make sure you go outside of the square root. So the subtracting 1 is outside of the square root. So I have the square root of 3/2 minus 1, and then I would also have it has to be a negative square root of 3/2 is the other one. So I'm going to copy and paste that. Oops. This. And make that a negative. So one of them is at 0.22 and one is at a negative 2.22. So let's go back to the graph so we can see those on the graphs. So one is at 0.22, so that's going to probably be right about here, and the other one is at a negative 2.22, so just past the negative 2. So that's the vertex is our bottom, and then it starts going up. So it's going to look something like that. Let's skip B and let's look at C. Make sure you get a chance to have a good representation here. So, let's see here. So our vertex, H and K, so H is a 1 and K is a positive 4. A is equal to a negative 4 this time, which is less than 0, so it's face down. So let's just get a glance here what it looks like. So my vertex is over 1 and up 4. So something right about here. And then it's face down. So I know I'm going to have 2 x-intercepts, right? I just have to figure out what they are. And then our y-intercept here is when x is 0. So that would be a negative 4 times 0 minus 1 squared plus 4 equals a negative 4 times 1 plus 4. So that's going to be 0. So negative 4 plus 4 is 0. So it looks like my y-intercept is at 0, 0. So there's that. So that's one of my x-intercepts too. That's pretty cool. I found when 0, 0 is used, then it's actually an y-intercept and an x-intercept. Okay, and so let's see if we can find the other x-intercept. So that means I'm setting the whole equation equal to 0. I'm going to subtract this 4 first. So a negative 4 equals a negative 4 times x minus 1 squared. Dividing by a negative 4. I get a positive 1 equals x minus 1 squared. And taking the square root of both sides, I get plus or minus 1 equals x minus 1. And so that means x minus 1 equals a positive 1, or x minus 1 equals a negative 1. So it could equal 2, or it could equal 0, which we already knew the 0, but we did not know the 2. So there is the other one. There's the vertex. So it goes something like this. So it's just, I find it so cool that we can graph and learn so much about the graph all just by finding these things, and we don't even necessarily need Desmos. So let's look at example 4. It says for each of the following equations, find the coordinates of the vertex and indicate whether the vertex is the highest or lowest point of the graph. Okay. So I'm just going to do one of these and then I'm going to move on and leave them for the extra video. So B and C are going to be on the extra video. Okay, so A is equal to a -1, B is equal to 6, and C is equal to -5. So we just want to find the vertex. And it's not in vertex form, so I have to use my A, B, and C. So the X coordinate of the vertex, remember, is the opposite of B over 2A. So that would be the opposite of 6 over 2 times the -1. -6 over -2 is a +3. And so when I put 3 back into my function, remember this is the opposite of 3 squared. So that is a -9 plus 18 minus 5 is 9 minus 5 is a +4. So my vertex is equal to 3, 4, and A is a -1 and it's less than 0, so it's face down. So my vertex is the maximum point. And we can see that because we know from A that it's a face down parabola, so that means my vertex must be the maximum point, the highest point. Okay, remember B and C are going to be on the extra video if you want to watch it. And then let's look at the applications. So we have a company selling picture frames finds that it can make a profit of P dollars each month by selling X frames, according to the formula here. How many frames must it sell each month to have a maximum profit? What is the maximum profit? So how many frames would be the X and the maximum profit would be the P? So to be honest, when it's the applications, I see no other reason than why you can't just use Desmos. So let's go to Desmos and put in our equation. Getting some Desmos practice is always good. So I'm going to put in, I'm going to just say y equals, and it's a -0.002x squared plus 5.5x minus 1200. Okay, so we're going to have to do some zooming out. A lot of zooming out. Because we want to find the maximum. So it looks like right there is our maximum. And so I'm just going to write that point down on my paper. 1375, 2581.25. Now we could over here just calculate the X value of the vertex because that's going to be our maximum value as well. And so that would be the opposite of B, which was 5.5 divided by 2 times A, which was a -0.002. And that 1375 confirms what we found on the graph right there. Pretty cool. So let's go back to our paper here. And I wrote down my vertex. So this is my vertex. And so it looks like that's the number of frames, X, that they could sell. And then this would be their profit. $2,581.25 for the month. Let's look at B. A company finds that it can make a profit of P dollars each month by selling X patterns according to the formula here. How many patterns must it sell each month to have a maximum profit? What is the maximum profit? So we want to find X and profit here. So I'm going to do the same thing. I'm going to find my vertex and then go from there. So let's head to Desmos. So it looks like I wonder if this is a typo. No. So it's going to have a loss. It's never going to make money because must be their costs are too high. This $800 is too high. And you can see that we never go above zero on our profits. So this is an example where they might want to rethink their business plan on that one. So let's just go back and make a note of that here that will never have a profit. Well, catch me back for the extra video if you'd like to get more help with these graphs.